Hello, in this video we will be seeing how to add two integers without using the plus and minus operators, and we will be building a solution in JavaScript and compute the time complexity and space complexity of the solution that we will be building here. The approach that we will be taking to reach a solution is going to be bit manipulation, and we will be using a technique called as bitwise sum. And this technique basically involves using three operations, and these operations are using a AND operator, using a left shift operator, and using a XOR operator. Using these three operators, we will be doing sum of two integers, and there is no need for plus and minus operators to reach a outcome. What we will first do is, let's say you have input as A, which is 1, and B, that is 2, and I need to add these two values. The binary representation of A is 0, 0, 0, 1. Similarly, the binary representation of B is 0, 0, 1, 0. Step 1 is that we will be using AND operator between these two integers in their binary form. So what we will do is we will say AND both of this, and the output is going to be 1 and 0. Both have to be 1 for the outcome to be 1. If 1 is 0, the outcome is 0. 0 and 1, similarly here also 0. 0 and 0 is 0. 0 and 0 is 0 for AND operator. And this was step 1. Step 2 is using a left shift operator, and we will be doing a left shift by a place of 1. So we will shift everything to the left by one place. So this will go to the left, this will go to the left, this will shift, this will also shift. After this shifts here, this is 0, this is 0, this is 0, and this is gone. And the empty space here is filled with 0. And this is what we are left with after a AND operation and left shift operator. So we performed two operations in bit manipulation, and the final operation that we need to perform is XOR. So what we will do is we will take A, which is this one. We will say 0, 0, 0, 1. We will take B, that is binary representation 0, 0, 1, 0, and we will do XOR of them. 1 XOR 0 is 1, 0 XOR 1 is 1, 0 XOR 0 is 0, 0 XOR 0 is 0, and we get this one. So we did the third operation also that we said we will be doing in this bitwise sum approach using bit manipulation. Then what we will do is this value that we have, we will assign to a A, and this value we store somewhere in a temporary variable before doing XOR. And then after we do XOR, what we will do is we will override this value and assign it to a B. So B becomes this temp value that we have. And these three operations that we performed, which was AND, left shift operator, and XOR, we will keep doing them in a loop till B is not equal to 0. When B is 0, that will mean that we just have A and there is nothing else to do sum with, because you just have A now. Just one integer is left. And then we just return this one integer that you are left with, which we keep on overriding using this three-step approach that we mentioned. And that's pretty much the core of our solution that we are building here. Now let's just translate this into code and see how it looks. So when we convert this into code, it will look something like this. First we said that let's use this temp variable and do A and B and do a left shift operator by doing a left shift by 1 bit, and then we override the value of A with A XOR B, and then we said that we will override the value of B with our temp, and in the end we are just going to return a A. And we said that we will keep doing this 3-step process till we have B not equal to 0. So B not equal to 0, while this keeps happening, we will just say that keep doing this 3 steps that we mentioned, and in the end just return a A that you are left with. And that's pretty much how it looks in terms of code. And in terms of the time complexity, it will be big O of 1. You will say, why big O of 1 when you're having a loop here? This is dealing with bits, and we can have at max 32-bit integers, and this loop can keep running worst case 32 times, because as we keep doing this left shift, we can do it max of 32 times because we can have 32-bit integers here, and it cannot go beyond 32 times when we keep doing this left shift. So this is like carry operation, then we do this XOR here, and then we override. So it cannot cross 32. That's why, because 32 is a constant, we say time complexity is big O of 1. And in terms of space complexity, that will also be constant, which is big O of 1. Reason being that we're just using a temp variable here, and we are overriding the value of A itself and B itself. We are not using any extra storage here. And that's pretty much it. Thank you for watching. Please like and subscribe. Bye.